Alright, so I got a couple projectile motion questions. Here is the first one. A ball is thrown 37 degrees above the horizon at 25 meters a second. Will it clear a fence that's 30 meters away and 6 meters tall? If so, by how much? So I'm just going to do a quick little drawing here. So ball is thrown. It's going to make something like this, right? Actually, here, let me draw that better. So this is V naught right here, so 37 degrees. That's V naught. And then 30 meters away from it. So 30 meters. There's a fence up like this that is 6 meters tall. And now there's two possibilities, right? So I'll draw in blue possibility 1, where it kind of comes up like this, and then it's going to go down like that. Actually, more something like this, actually. Or there's possibility 2, where it's going to go something like this, right? And it won't clear the fence. So what I would do in this scenario, so this is 30 meters, right? 30 meters. I would find the height after 30 meters. And then I would just see, is it above 6 meters or is it below 6 meters? Because if it's below 6 meters, then obviously it didn't clear the fence. But if it's above 6 meters, then let's say it's up here, for example, then there's no way it would hit the fence, right? It would definitely go just like down over there. So that's what I would do. So let's find out the height at 30 meters. So let's just draw the height equation. So it'll be delta dy equals, and then it's sine 37 times V naught plus, actually this would be minus because gravity's down, right? So 4.9 meters a second squared. And then actually, hold up, I made a mistake here. So V naught times delta t subtract 4.9 delta t squared. Okay. Now there's two unknowns. So there's delta dy and then there's delta t. So you're going to use another equation here, which is delta dx, to solve for delta d, or to solve for delta t. So delta dx is going to equal delta t multiplied by cos 37 degrees times V naught. Right? So if you rearrange V naught in this case, or sorry, yeah, rearrange, so you move this all the way to the other side, then you're going to get 30 divided by cos 37 degrees times V naught. And that would equal delta t. So now you're going to take this entire thing right here and you're going to put it back into this equation. So let's do that now. It's going to be very messy, so I'll skip ahead and kind of put this in. And then also V naught is 25 meters a second, right? Yeah. So V naught's 25 meters a second, so I'll just replace it in here with 25 meters a second. And this is all squared. Okay. So that should be good. And then one thing to note here, so there's V naught over V naught, so you can just, actually, sorry, that's too big here. Yeah, you can just erase these. There we go. Okay, so this is what I have now. And now I should be able to solve for delta dy now. So delta dy, and you just put all these numbers into your calculator. And you should get a number. So I'll just skip ahead to what that will look like. So this is going to be 22.6 and then minus 11.06, which will equal to 11.53 meters. Of course, it's positive as well. So that means at the 30-meter point, it's like this high up. So it definitely crossed it. So we'll say, yes, it crossed it. So here, check mark. Will it clear the fence? Yes. If so, by how much? So what you're just going to do now, you just subtract 6 meters. Subtract 6 meters. And so you should get 5.53, round to 5.54 meters above fence. Okay, so let's do the next one. A soccer ball is kicked 40 meters a second. It lands 80 meters away. What angles could it be launched from? So here, I'll just draw this really quick. So soccer ball is launched up like this, lands over here. It's 80 meters away. And then, so V naught, the magnitude, is equal to 40 meters a second. So there is a special equation you can use for this. It's called the range equation. So I'll just write it in. Range equals, it's going to be sine 2 theta and then V naught squared over 9.8 seconds squared. Okay. And now what you do next, so we're just going to rearrange. We're trying to find the like theta, right? So we'll just rearrange. So range is 80 meters in this case. So I'll do 80 meters times 9.8 meters a second squared. And then divided by 40, which is squared meters a second. And that is going to equal sine 2 theta. And then you're just going to do inverse sine. And the number you should get after this, so let's just see, what should this equal? So before you do inverse sine, it should be 0.49 equals sine 2 theta. And then inverse sine, so then you just get 29 point equals 2 theta. But now notice how it says 2 theta here, right? So what you have to do next in this case, so there's two options for theta in this case, right? So because if you remember, like if you remember the chart here, right? So sine 2 theta, so that's something like this, right? So if you remember the cast rule, so cast, actually sorry, C-A-S-T. So 29.34, that is like right here, so 29.34, 29.34. Alright, but it's half of that. So it's half of this number right there, divided by 2, and then it's going to be half of this number right there. So what you're going to do, there's two options. So option number 1 is going to be 29.34, 29.34 divided by 2, and then option number 2. So again, see how this whole thing right here would be 180 degrees, right? But it's not quite 180. It's 180 minus 29.34 divided by 2. So now after you do both these, the numbers you should get are about 14.7 degrees and then 75.3. Yeah, those are the two ones you should get. So equals theta. So theta has two options, and then those are the two numbers you get. So remember this formula. Range equals sine 2 theta times v naught squared divided by 9.8. And then also be able to show this as well. Don't just like memorize this thing right here. You also got to like demonstrate that you know what's happening. All right, that's all for projectile motion. All right, here's